All right, you guys, welcome to 7-3. We're going to talk about triangle similarity. Specifically, we're going to talk about angle, side, side, and side angle side similarity. And first of all, I'd like to go through the math humor. My esteemed colleague, Mrs. Kubasek, is not here with me, so you're going to have to bear with me. I'm going to ask you, what do you call a fierce beast? A lion? A lion? Get it? Lion? Rawr. All right. I know, they don't get any better, you guys. Just deal with it. Go along with it. They're math jokes. So the first one that I'd like to go over is the angle similarity. Okay, this simply says if two angles of one triangle are congruent to two angles of another triangle, well then these two triangles are actually going to be similar to each other. This is the symbol we use for similar, remember? So you're going to get problems that say this, hey, I want you to explain to me why these triangles are similar, and then write a similarity statement. Well, first of all, you have to explain why they're similar. So I would say something along the lines of, well, we know that angle A is congruent to angle D, right? These are congruent because they're right angles, so this is the right angle theorem. Remember, you always have to justify what you say. Use that proof knowledge that you have. We also know, right here, we have what type of angles? Vertical angles. So we would say, we also know that angle BCA is congruent to angle ECD, and this is your vertical angle theorem. They're congruent. Therefore, now I'm going to show you something. These three dots right here are, in short, the words therefore. I know it's really weird, but us math people like to shorten everything, and those three dots mean therefore. I would write that down because I'm going to write this a lot. Therefore. So therefore, now this is where your similarity statement comes in. Okay, therefore, your triangle ABC has to be similar to triangle DEC, and this is by angle similarity. Okay, so let's go back and see what we did. It said, why are the triangles similar? Well, we said we saw that two angles are congruent here, two angles are congruent here. We justified it. And so therefore, angle similarity, so we wrote our similarity statement. All right, the next one is side similarity. This one's pretty self-explanatory. It says if the measures of corresponding sides, so the sides that match up, are proportional, then the sides are similar. So for instance, let's take a look. This side and this side match up. That sets up a ratio of 9:3. When I reduce this, this is a ratio of 3:1. So this is 3 times as large as this side. Now let's go to the next sides. These two sides, oops, I'm sorry you guys, I thought I hit the button. These two sides here also match up, so let's take a look. This gives me a ratio of 12:4, which is also 3:1. So far so good. We are matching up here. And lastly, these two sides match up. This is a ratio of 15:5. Also 3:1. So because all three sides are proportional to each other, meaning that all three ratios are equal, these two triangles are congruent by side similarity. So now, you're going to get examples that ask you to verify that the triangles are similar, just like we did before, okay? So now let's take a look. Let me see if I can move this up for you. There we go. Let's take a look here. We have our sides matching up. It tells you that PQR, so I got PQR, and then STU. So let's look here. I have PQ and ST matching up. So PQ and ST. So this is a ratio of, let's see, I'm just going to write this, PQ and ST. This is a ratio of 3 to 4.5. And now I'm going to simplify this. This gives me about, what is this, 2 to 3. So this is about 2/3 if you actually go through and divide this. Our next is QR and TU. So QR and TU. So QR and TU. This is also 3 to 4.5, which is 2/3. If you don't know how I'm getting this, you guys, use your calculators. Divide them. Your calculator will give you 0.6 6.6, so on and so forth. And then the last two sides are an actual ratio of 2 to 3. So what you'll notice is that all three sides, I showed all three sides, these are PR and SU. All three sides are actually proportional, okay? So because they are, triangle PQR is similar to triangle STU because of side, side, side similarity. All right, this last one talks about side angle side, okay? So it says if two sides are proportional to two sides, and then the included angle, meaning the angle in between those two sides, has to be congruent. So proportional sides, congruent angle, then that side angle side similarity. Okay, so if you take a look, we have 2 to 3 and 4 to 6. So 2 to 3 and 4 to 6, which is also 2 to 3, leaves our sides proportional and the angles are congruent. So these two triangles are similar by side angle side. So the classic example that you'll get is verify that these two triangles are similar. Well, we know, let's start off, we know that angle D is congruent to angle H, right? This is just the definition of congruent angles. They're the exact same, right? So these are congruent here. We also have to check our sides now. So we see, let's see here, DE matches up with HJ. So let's look. This is a ratio of 2 to 1. Okay, which is what? 2. All right, so now let's check our other sides here. Our ratio of, let's see here, DF to HK. This gives me 5.8 to 2.9. And when I divide that, it's also 2. Check that out. So our two sides are proportional to each other. Are these similar? Why, yes, yes, they are. So therefore, remember your similarity statement, triangle DE, that's not a D, DEF is similar to triangle HJK, and this is by side angle side similarity. All right, we're going to work with this first example here. It says find the lengths in the similar triangles and then explain why these two triangles are similar, and then you're supposed to find CD. Okay, so we have a couple things we need to do. Number one, you have to verify that the triangles are similar. So number one, verify triangles are similar. So let's take a look at this. We have three different ways. It could be by angle, angle. It could be by side angle, side, or it could be side, 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 right? Well, we're missing one of our side lengths here. So really the side, side, side thing won't work. Side angle, side thing won't work because we don't know the length of that. I do see, however, that they share an angle here. They overlap here. And we have two right angles, making those congruent. So I know that I can verify these triangles are similar by angle, angle. So I'm going to write that out, okay? So in this first step, I know that angle A is congruent to angle A. That's reflexive. All right, so that's here. I also know that angle B is congruent to angle C. Well, they're both right angles, so that's the right angle theorem. So therefore, triangle ABC is similar to triangle ACD, and we did this by angle, angle similarity. Okay? So now that I know that they're similar, now I can go ahead and find what they want me to find. They want me to find CD. So step number 2, we're going to actually find what they want us to find. So in this case, it's find CD. And I can set up my proportion. Set up the pieces that match. Well, I know that these two match up, right? So X goes to 5. And then the larger one here, 9 plus 3 is 12. So 12 would go to 9. We know how to do this from 7, 1. You cross multiply, use your cross products. You get 9x is 60, leaving you with x being 6 and about 2/3, or 6.6. The second application actually comes from an engineering problem. It's an engineering application. It says the photo shows the gable roof. So it says that AC right here is parallel to FG. It tells you that these two triangles are similar, so it's the large triangle and then the small triangle up top. Find BA, so I want to find BA, which is the long thing here, to the nearest foot. Okay, remember step number 1. Verify the triangle similarity. You have to know that they're similar first. Okay, well, I can see that these angles are actually congruent because if these lines are parallel here, I've got some F's. I've got corresponding angles, so I'm going to use that. I know that angle F is congruent to angle A. I also know that angle G is congruent to angle C. This is the corresponding angle theorem. Okay, therefore, triangle ABC is similar to triangle FBG, and this is angle-angle similarity. Now that I know that these are congruent, let's go ahead and solve. I'm going to erase some of this stuff because I wrote all over my picture. So let's use a different color here, something that's a little bit brighter, maybe green. I like green. You guys like green? All right, so I want to find BA, right? Okay, well, in order to find BA, I have to know this little piece here. I'm going to call this piece X. If this piece is X, that leaves the whole side here to be X plus 17. So now let's compare. I know that the big one to the small one, so X plus 17 matches up with X. And then if I go the other way, I know the big one to the small one, I have these sides, 24 matches up with 6.5. So now use your cross products, okay? You end up with 6.5x plus 110, oops, that's not 110, 110.5 will equal 24x. Remember, you have to distribute the 6.5. When you go ahead and solve, you get that x is 6.3 feet. Now, if I want to find BA, BA is the whole thing here. You just add that on. So 6.3 plus 17 gives me 23.3 feet. Before going into this next section, I just wanted to remind you, in Chapter 2, when we did all of those proofs, we were talking about reflexive, symmetric, and transitive properties of equality, right? Okay? I want you to know that equality also holds for congruency, which will also hold for similarity, okay? So the reflexive property works with similarity statements as well. If something's similar to itself, that's considered the reflexive property. If you flip either side of the similarity symbol, that's the symmetric property. And then your transitive property is cutting out that middle man there. If A equals B, B equals C, then A equals C. It holds for similarity as well. All right, so I want to go through and ask you, are these similar, yes or no? And if so, you tell me, angle, angle, side, or side, side. So if you take a look at the first one, in order to look at this, angle, angle, we don't have two angles here. We only have one. Side, I don't have all three sides, so I can't do that. The only one that I could possibly prove for is side, angle, side. In order to do that, I have to check my proportions for my sides and then look to see if the angles are congruent. In this case, the angles are congruent, so we're good there. And now let's look at our proportions. 5 to 10, which is 1 to 2. And then 7.5 to 15, which is also 1 to 2. So yes, these are similar by side, angle, side. I would like for you to please do these three and then come back and then we'll see if we have the same answers. Okay, so what you should have noticed is the second one, we have all three sides, so you should have tested side similarity. And when you look at the ratios, you think you kind of sort of have it, but that last one, this 21 and 15, just don't cut it. So remember, all three have to be the same in order to give yourself a yes on that side. The third one, two angles, congruent to two angles, so that's angle, angle similarity. And here, it can't be angle, angle, can't be side, side. It also can't be side, angle, side. Remember, it has to be the included angle, so it would have to be a side, then an angle, then side. We have two sides, but it's not side, angle, side. So there's not enough information to tell if these two triangles are similar. All right, this next one, find Z. Well, let's take a look here. I have a small triangle, and I have a large triangle, right? And I'm not sure what happened here, but you are given information, or you should have been given information that tells you that RT is parallel to XY. So these two are actually parallel to each other. So first of all, you need to see, are these similar? Well, they share an angle here, and because these are parallel, your corresponding angles also are congruent. So yes, by angle, these are similar. So now you have to actually go ahead and set up the proportion. We have a small triangle here, and we have a large triangle here. Now the large triangle, this side right here, is 14. So 14 matches up with 5. So 14 is to 5. And then 7 matches up with what we want, the z. 7 is to z. So when I do my cross multiplication, I get 14z equals 35, making z 2.5. I would like for you to try the second one, please. So pause, try it out, and then we'll see how we do. All right, so yes, angle, we have the two right angles, and then these are congruent. Now you have to flip this one. If it helps, turning this one this way, so this triangle right here, so that this is x and this is 12. So 12 matches up with x and 18 matches up with 12. You should have gotten, after you work your proportion, you should have gotten that this is 8. Last example, please solve for x. All right, so taking a look, again, angle, we have vertical angles and then the two congruent angles here. So if I have to turn this just to see, 14 matches up with x, and then these two back sides here, the 12 and the 9, these match up as well. When you cross multiplied, you should have gotten that x is 10.5. Okay, that does it for Chapter 7. We're going to be doing some in-class review. You will be having a quiz coming up. And if you have questions, please make sure that you bring those to class. Thank you.